Hello, distance learners. I'm Miss Becker. I'm your math teacher, and we are going to start taking notes today for the first time in class. So I was going to share with you the notes that we took to help you with some of your work for this week. I'm also going to try and get tomorrow's notes done as well, so that you can have at least 2 of the 4 days of lectures while you're working. I've seen lots of you turning in work so far today. That's awesome. We just want to make sure that we're getting it in correctly. So let's go ahead and kind of start talking about some of our definitions for the week. Our learning target this week is 6N 1.5. You should be able to factor whole numbers and express prime and composite numbers as a product of prime factors with exponents. So today our focus is being able to describe and identify factors and what that word means and what those look like. In order to do that successfully, we want to be able to list all factors of a given number 85% of the time. So to know if we're successful or not, we are taking apart our learning target and doing piece by piece, making sure we understand what we're looking for and what success actually looks like. So to be able to express prime and composite numbers, we need to know what those are. So prime numbers are numbers whose factors are 1, that's the number 1, and itself. So prime numbers, only factors it has are 1 and itself. Composite numbers are numbers with more than 2 factors. So an example of a prime number would be like the number 7. The only factors of 7 are 1 and 7. An example of a composite number would be like 49, because 1 and 49 are factors, as well as the number 7. You need to know what the definition of product is, as we are expressing them as a product of. Product is the answer to a multiplication problem. It's that simple. It's just the answer to a multiplication problem. We need to know what factors are. We talked about factors when we defined prime numbers. We talked about factors when we defined composite numbers. And the word factor is in our learning target. So we need to know what those are. Factors are the number that can be multiplied to create a specific product. The numbers that can be multiplied to create a specific product. Those are your factors. And factor pairs, that's 2 of something. So it's going to be the 2 numbers that can be multiplied to create a specific product. So here in school, we have composition notebooks that are just for math, and that's where we're taking these notes. I would strongly encourage you to write these notes and these definitions down in a safe place that you'll have them, where while you're working you can look back at these definitions and these examples that I'm about to do and have a frame of reference and maybe a little help along the way. So we are going to see what it looks like to start finding and listing factors of a number. So one way to kind of make all of this into a problem would just be that a factor times another factor equals your product. Okay, so in factor problems, you are given the product and you have to find the factors. So you're given the answer and you have to find what two numbers can multiply together to get to that number. 1 is a factor of every number and is where you would start. So 1 times the number itself gives you 21. So that is a factor pair. Then you'll use the divisibility rules that I shared with you 2 weeks ago to find the remaining factors. 21 ends in 1, so 2 will not go in it. Then you think about 3. Well, I know that 2 plus 1 is 3, and if your numbers add up to a multiple of 3, then 3 is a factor. So 3 times, if I think I know my math facts, so it would be 3 times 7 is 21. If I don't know my math facts, I could always do 21 divided by 3 and get my other product, because division is the opposite of multiplication. So you could always do that to find the missing number as well. Then you would ask, can 4 go into 21 without a remainder? No. Can 5? No, because this number is not 5 or 0. 6, no. 7 we know can, so we have found all of our factors because we're going to start repeating. So we know we have all of our factor pairs. Then it says list the factors. In order to list the factors, you're going to put them in order from least to greatest. So you're going to take the 1, the 3, the 7, and the 21. And those are your factors. We're going to do another example. List the factor pairs of 81. So something times something equals 81. We have to find all of the possibilities. We know 1 and 81. Then think of 2. No. 8 plus 1 is 9, so we know 3 is going to go into it, but I'm not sure how many times. So I'm going to divide 81 divided by 3 to see what my missing product is. 3 goes into 8 2 times. 2 times 3 is 6. That leaves me with 2 left. 3 goes into 21 7 times. We said that right up here. So 3 times 27 equals 81. So that's another factor pair. 4 does not go in it. 5 does not go in it. 6 does not go in it. 7 does not go in it. 8 does not go in it. Oh, but I know that 9 times 9 is 81. So to list my factors, I'm going to say 1, 3. I'm only going to put 9 one time, 27, and 81. One more example. List the factor pairs of 56. Again, just to make sure, we're going to list out all of our numbers. We'll at least go to 12. That'll get us started. We know 1 is a factor of every number, so 1 and 56. 56 is an even number, so 2 will work. So 2 goes into 5 twice, 2 goes into 16 8 times, so 2 and 28. 3, 6 plus 5 is 11, so 3 will not work. 4 goes into 5 one time, leaves 16, so that's 14. 5 will not work. 6 will not work. 7 times 8. I know I'm finished because I'm going to start repeating factors from here. so I can stop. Again, list the factors in order from least to greatest. You take the first number in each set, going left to right, and then you take the last number in each set, going right to left, and they will be in order from least to greatest. How do you know you have found the factor pairs of any given number? The factors start repeating. I hope this helps. I know that I gave you, one of the options was to be able to play the factor tree game. So I'm going to show you quickly what that would look like if you were going to be playing it by yourself or with a friend at home. Here is the sheet. Oh, let me get out of the way. Okay, here's the sheet that I have on Google Classroom for you. You're going to just take 2 dice. You can pull them out of any game that you have. You're going to roll the dice. You can't really see that, but I rolled a 32. So I am going to write 32 on this line, and then I'm going to list out my factors of 32. If you're playing against somebody, you see who can do this the quickest. If it's just you, that's great. Also, we're just getting practice. Excuse me. 1 is a factor of every number, so we'll start with that. 32 is even, so we know 2 will go into it. That would be 16 times. 3 will not work because 3 plus 2 is 5. 4 times 8 is 32. 5 does not work. 6 does not work. 7 does not work. 8 works, but we would be repeating. So we have our factor pairs. So then we're just going to list our factors in order from least to greatest. You would just type that in. So you would type all of this in to the sheet on Google Classroom. I will do one more for you, just one more set of practice. Oh, I got 22. That'll be a fun one. 22 is what I rolled. Remember, if any number repeats the same digit, it is one of the factors will always be 11. So we'll do 1 and 22, 2 and 11. 2 plus 2 is 4, so 3 will not work. 4 does not work. That number is not 5 or 0, so 5 does not work. 6 does not work. 7 does not work. 8 does not work. 9 does not work. 10 does not work. We're back to 11. So 1, 2, 11, and 22. I hope this helps. I'm going to stop this video because this is just factoring, and then I will start a new video for prime factorization.